identify those for yourself, those patterns. And then the coefficients, the connection with Pascal's triangle. Well, I don't know. Take one of them and look at it and see what you think what the pattern is there. Okay, well, let's see if you have the pattern first. Try and write out this one without doing it the long way. What's the pattern? Try writing that out. What's that going to be? What's the first term going to be? It's got to be, the first term's got to be a to the fifth, right? What's the last term going to be? B to the fifth. It's the middle ones that are the harder things, right? Without the coefficients, let's leave the coefficients out for a second. We'll just put a blank. What are the patterns in the variables going to be from one end to the other here? You're going to have something that's a to the fourth times b, right? Are you going to have something that's a to the fourth, b to the fourth? You can't, right? Because this is a 5, you're not going to have that, right? Nothing. If this is a 5, the total on each of the terms is going to be 5. And then you have, what's the next one going to be? A to the third, b to the second. And you're also going to have, leave a space for the coefficient in there. A to the second, b to the third. Which one am I missing now? A to the first, b to the fourth, right? And then plus b to the fifth. If you look back at the other ones, that happens every time. And maybe you don't. Maybe you're not seeing that this is a 1 here, right? On the ones by themselves. The pattern in the powers here, pattern in powers of A, 4, 3, 2, 1, and what is it over here when there's nothing there? It's 0, right? And pattern in the powers of B, well, 0, 1, 2, 3, 4, right? If you've written it in an organized way, its powers of 1 are decreasing, right, from whatever this is. If you have A plus B to the n, powers of A are going to go from n down to 0, right? And the powers of B are going to go from 0 up to n. And then the coefficients, where are the coefficients? Coefficients of this one are 1, 4, 6, 4, 1. These are from a particular row of Pascal's triangle, right? For this one you actually have 5 brackets here, right? 5 factors. There's 5 factors, and all the terms are going to come from choosing an A or a B from each factor, right? There's only one way you can choose all of them, an A from all of them, right? So this is why this is a 1. How many ways are there you can pick an A from 4 of them and a B from 1 of them? There are 5 ways, absolutely, right? You can think of this as from the 5 brackets or from the 5 factors, I am going to choose one of them to be a B. Or you can think about it as, or you can think about it as A. It's going to be symmetric, right? It's going to be the same as the other side here. From 5 factors, how many ways can you choose one of them to be where the B comes from? And this is going to be 10 for the same reason. This is, from 5 factors, how many ways can you choose 2 of them to be a B? And then 10, and then 5, and the last one's a 1 again. Okay, the coefficients come from Pascal's triangle, or in other words, combinations. Okay, numbers of ways you can combine things. This you want 4 A's, right? And a B. So from 5 factors, how many ways can you pick that one B? Well, it can come from that one, from the first one, the second one, the third one, the fourth one, or the fifth one. Can you try and write out the pattern, write out the expansion for this if you've not already done that? If you have done that, you can go ahead at looking at writing it out and making some sense of this. Okay, read that and make some sense of that. And then you can try doing some of the expansions here. Okay? You can try expanding this where it's not A and B now, but using the shortcut. And then I'll put this up here in a minute. If you're trying to do this, I mean, there's kind of two steps here, right? You need to think about what the variables are going to be, right? If this is a 6, once you multiply out, 6 brackets, I'm not going to write them all out, but if you have 6 brackets there, you're not going to get anything higher than 6 as the total degree or the sum of the powers on the variables, right? You're not going to get e to the 4th, b to the 7th. It's too, you can't get that many because there's only 6 brackets you're multiplying out, and you're always only multiplying one variable out of each bracket. These terms, the ones that have a number other than 1 here, is because as you're multiplying it out, there's more than one place that comes from, right? Like the very first one you did, that you got a squared plus ab plus ab plus b squared, there was 2 places the ab came from. An a out of one bracket, a b out of the other, and vice versa. As you keep going here, there's lots of places this comes from. Think about it as from the 6 brackets, okay, there's 6 factors, but you're only having one b, right? So this is going to be 6c1, or this is a 6. This one is going to be, you're choosing 2 b's from the 6 brackets, right? So this is going to be 6c2. What does that give you? 15 or something? And then if you keep going here with this, leave that coefficient out for a second here. This is a to the 3rd, b to the 3rd. We have a squared, b to the 4th. I'm going to run out of room, but a, b to the 5th, plus b to the 6th. As far as those coefficients, this is going to be choosing 3 b's from 6 brackets, or 6 factors. This is going to be choosing 4. That's choosing 5, but at this point there's the symmetry to it, right? This is, you're choosing all 6 b's, there's only one way, right? That's a 1. This is 20 here if you work out what 6c3 is, but there's going to be some symmetry to it because this is going to be, 6c4 is the same as 6c2. That's going to be the same, and that's going to be the same. The pattern's illustrated on the next page using combinations. It's written out where the coefficients are these, right? Those numbers. If you actually worked out the coefficients here, the simplest way to write this would be a to the 4th, right? 4c0 is just 1, right? 1, and b to the 0, you don't really need it there, right? This is 4 a cubed b. This is 6 a squared b squared. That's 4a b to the 3rd, and then this is just 1 b to the 4th, right? It's a number of ways you can choose those things. Okay, number of ways to choose that many b's from 4 factors if you happen to be doing 4, right? Lots of things to notice in the pattern there, right? And maybe we're trying to rush it a little bit, but if that's a 4, the total of the exponents, the degree, you call that the degree of each term, is not going to be more than 4. It's going to be 4. Okay? The degree of each term is 4. That adds up to 4. That adds up to 4. Every single one of them adds up to 4. Next time we're going to look ahead at, or we're going to look not ahead. You want to be able to apply this now for when the thing isn't just a and b and it's other numbers, because it's not going to look like the pattern appears. But you can use the same idea. All right?